For most of you who know me, my shtick is cheap robots. The MopBot that I push, it's made out of snack discarded containers, popsicle sticks, 3D printed parts. It's simple Arduino Nano. The MopBot, basically it just does, the other thing is because it's so cheap, when it falls, it shatters. Both of these I broke about a half hour ago and just had to super glue them together. So this is tabletop 1. I'm now upgraded it to MopBot 2, just these cheap little things, and a Raspberry Pi that goes on top of it. Of course, it's no longer attached as of a half hour ago, but this glues on the top. Attaching to the Raspberry Pi is really easy. I just use VNC that comes with Raspberry Pi, and you just get the VNC viewer. It's free.
I'm sorry, DNC is what?
VNC.
Oh, okay.
What's great about it is I didn't know if it would work here, but I just powered up the Pi headless. It found an open Wi-Fi connection, connected to it. I opened up my laptop, ran my VNC viewer, and it goes to its servers and says, okay, yeah, I found all of your robots. And I can connect to it headless really easily, and so now I'm controlling the Pi from here. What I've been playing with is some vision stuff, because last year I did, just using a ping sensor, was able to find the object, find the goal, and using a really simple neural network, the Arduino Nano would find the object and then corral it into the goal. I wanted to do something different for this year, so I figured I'm going to upgrade to vision. And the cheapest way to do that is Raspberry Pi with the camera. So imagine that this is attached to the top. Can someone come and hold this and like point it at the whatever you find interesting? And then I'm going to come over here and just take a quick picture. We'll call it B. Sure, that works. So I'm just using the Raspberry still to take an image. And then I have an image analysis program that I run. And we see it found objects. It's all based on color. So now let's see what it saw. So this is what it saw. And I guess the lighting's not too good because these are the objects it thinks that it sees. So it sees the top of the yellow. It sees the table surface as a single object. And it sees the green cube. That's not a very good picture.
Osman.
There it is. Sorry. Here, point it out at the audience if this is good. So let's just take another picture. And I'll analyze that again. The parameter is 100, 100. The first one is basically saying, ignore everything that's less than 100 pixels. And the second 100, what does that mean? Oh, that's the threshold for the delta, the RGB delta between one pixel and another to determine if it thinks that it's part of the same object or not. So basically it doesn't emboss, finds the edges of objects, and if it's the same color, assumes that that is a single solid object. So let's see if this picture works a little bit better. And let's see what it sees. And so these are all the little objects that it thinks it sees as a single entity. The next phase, of course, is I'm going to use 2 of the blocks as the goal for tabletop and then a different color for the object. So that way all it has to do is like find the 2 green squares, find the red square, and push it in between, and that will be tabletop challenge 3. And that's pretty much it. These are really cheap to build. A few people have built them already. If you want to make one, come see me. Real easy.
Question. Would
Yes.
K-means analysis give you the partitioning as well? Is there
Say that again?
using K-means analysis to find 32 objects or something like that? Just
No, I'm just scanning the image and finding similar pixels of similar color. For
They don't
example,
have to
his
be-
shirt, it's all blue. So it thinks, oh, that's one thing. It notices that the badge is something else because it's a different color. It's all color-based. There's no depth at all.
And no connectedness. Anything that's that a shade of blue anywhere is considered to be part of the same object.
As long as that color blue is surrounded by non-color blue. It's just anything, it just basically does a flood fill. This is a really simple algorithm. I've been just experimenting with algorithms to see which ones work better than others. It's harder than it seems. Some straightforward algorithms end up showing you garbage. This is my most recent iteration. It seems to work well enough to find blocks, which is all I needed to do on Friday. But I'll continue to experiment with things.
Is this something that you're publicizing somewhere?
No one's asked me yet. If anyone's interested, yeah, sure.
GitHub.
I don't use GitHub. I don't like GitHub. I don't know why. I just have a neurotic prejudice against it for some reason. But I usually put stuff up on a Google Drive. Anybody who wants, I just send out links. So, and also, if anybody's interested in exploring these algorithms too, it'd be great to have people to work with. So.
And then it will be given.
Any other robots?
Oh, one more thing. I bought a bag full of IMUs, and if you're already taking names to give away something, I'll use that same list and give away a free IMU to whoever wants one.
What's the IMU vendor? You know?
I don't know. It's the little $10 9DOF or 10DOF IMUs. I have a bag of them.
Maybe in cents, maybe. Okay. Cool. Thanks.
So for those of you who were here last month, I had an airplane simulator. I had 3 servos to control the ailerons, elevator, and rudder. Anyway, I got to thinking about it, and that worked pretty well. And I thought, you know, it wouldn't take a whole lot to turn that thing into a rocket. It only takes 2 servos. So, see it in there? Okay. So, I was going to make a mount for it, but I didn't. Anyway, it's kind of neat because somebody had brought in, they were talking about modular construction. It only took taking 2 screws out and screwing the rocket body in instead of the airplane simulator, and I have now a rocket simulator. So I guess I'm qualified now as a rocket scientist, right? Last month I was an aviation engineer. In any case, this uses I have a display up here. It's a serial display, which is nice because it only uses 1 pin to feed the serial display, so I can see what's going on with the 3-axis gyro. I have a 3-axis gyro here. By the way, the gyro itself is less, let's see, it's less than 1/4 inch on the side, 3-axis. I think this one is a propeller. You can buy these from the Parallax people. I'm using a propeller from Parallax as there. You could probably do the same thing with an Arduino if you like playing with Arduinos. Anyway, this thing right now is just simply using the gyroscope to control the nozzle with extremely simple, just to take the values of the gyro, scale them, and decide between 0 and 1500 what to give the servos. And I tried to make it so it would potentially try to correct the thing to make it go straight up. One of the things, I do have a lathe, so it was nice to, kind of fun to make a nozzle. And I was particularly pleased with the fact that I came up with a coupler, which looks pretty slick if you can see. I don't know if you can see that closer or not. If you'll notice the little coupler there between the control collar, that's all that is a motor coupler, which is flexible because I needed to have it be flexible. Okay, so if all goes well, we'll see if we can demonstrate this thing. Now, this one's a little trickier to demonstrate than the airplane was. I'll try to hold it straight up here. Get my fingers out of the way. Let's see. I don't want to get myself caught in it. Okay, I want to reset the thing when it starts. Okay, so I thought it would be kind of clever to see what happens if you do this sort of thing. Okay, so I don't have the thing set to do any real control on it yet, but you can see theoretically it would be trying to push the nose so that it makes it go straight up. Now this would be far too simple to actually do practically. If you wanted to actually go into something to be more realistic, you would need to change this and put in a full IMU, which I believe I'm in line for one of those, right? So I've looked, and you can buy an IMU from Adafruit for $34, or there's Chinese knockoffs for $8.50. That's a 9-axis IMU, so that's magnetic three-axis, accelerometer 3-axis, and gyroscope 3-axis. So there are algorithms to combine those all together, and that's what I'm interested in playing with, is those algorithms mainly. So that's the reason I just want a simulator. Microphone. So to simulate this, and then you can actually get into things called Kalman filters that you can combine all that information. And that's the way real rockets use. I did look up on the web to see, should you be messing around with this kind of thing? And I found a general consensus that said there's no laws that you're violating if you make something that just basically tries to make a rocket go straight up. But when you start adding things like GPSs and point of contact calculations and things, somebody might get interested. So, anyway, that's it. Any questions?
Has anyone not signed?